For our next presentation, which is Calculating Beauty, Mathematics in Art and Nature. And the presenter is Alex Wolfe, who is a junior, a math major. Hometown, Randolph, Ohio. Career plans. Alex plans to pursue a position in teaching mathematics at the high school level. Great. I'll turn it over to you.
Good afternoon, everybody. As she said, I'm a math major, not an art major, but today the subject is kind of where math shows up in art and nature, which I think is really nifty. So as you guys are walking in, you probably noticed this big slide up here. What do all these things have in common? And that's basically what we're talking about today, what these all have in common, Fibonacci numbers and the golden ratio in art and nature. And we're going to be getting into what exactly those two things mean. Just some definitions first so that we all are kind of on the same page. What is beauty? It's a very, very philosophical question. And as they say, beauty is in the eye of the beholder. And we could go on hours and hours about what beauty is. But just to make things simple today, we're going to say if the work of art is pretty much well accepted, well talked about as being beautiful, it is today. And now, what's Fibonacci? Or maybe more accurately, what is the Fibonacci sequence? The Fibonacci sequence is just a sequence of numbers where each term is the sum of the two that came before it. As you can see here, we start off with 0 and 1. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. And so on and so forth in infinity. It's the world's oldest known recursive sequence, and all that really means is that you can define it in terms of itself. If we say f of n is the nth term of the Fibonacci sequence, we can write it as f of n equals f of n minus 1 plus f of n minus 2. So basically, the nth term is the one that came before it plus the one that came before it. When f of 0 is 0 and f of 1 is 1. Now, who was this Fibonacci guy? Why did they name an entire sequence after him? His real name was Leonardo da Vinci. He was an Italian mathematician, and he wrote a number of different books and stuff about math, probably most famously Liber Abaci, the book of calculation. In this book, he answered lots of different questions and was using the Indian numeral system, the numbers we use today. At this time, they were still using Roman numerals, but in this book, he answers the question of how many pairs of rabbits are there in each successive generation of rabbits. And these numbers were 1, 1, 2, 3, 5, 8, 13, 21, so on and so forth. And these are the numbers that we know today as the Fibonacci sequence. And also it gives us where the rabbit on the first page came from. Now, what's the golden ratio? Sounds expensive. The golden ratio is a proportion. It's been referred to as a lot of different other things. The divine proportion, the golden mean, the golden section, the extreme and mean ratio, and lots of other names, too. But what exactly is it? It's a ratio of two numbers. The two numbers are said to be in the golden ratio when the sum of the two numbers over the larger number is the same thing as the larger number over the smaller number. When you have this, you get an irrational number that we call phi. And the first 10 digits of it are 1.618033988. And it keeps going on, not repeating. It's an irrational number. It's also considered the most beautiful proportion, which gives it its name, the divine proportion. So in case that big, long word version didn't make sense to you, all this is really saying is if a plus b over a is the same thing as a over b, the ratio is 1.618 to 1. And above you can see a golden rectangle, which basically means the side lengths of these are 1.618 along the top to 1. Because if you take that a plus b and divide it by a, that's the golden ratio. Now, why are these two things related? I've got this big long list of numbers and supposedly this pretty ratio. Let's use the f of n to talk about the nth term of the Fibonacci sequence. If we take the limit of f of n plus 1 over f of n, as n approaches infinity, the result approaches the golden ratio, or 1.618. So, for example, we just start off with the first two numbers. That's 1 over 1, that's 1. That's not very close. at all. But if we skip all the way down to the 8th number and the 7th number of the Fibonacci sequence, 21/13, that's 1.615. And if you keep getting larger and larger numbers, it gets closer and closer to the golden ratio. Another interesting relationship that Fibonacci numbers and the golden ratio have are golden spirals. A golden spiral is a logarithmic spiral, that's just that thing on the right, whose growth factor is phi. Basically what that means is that each quarter turn of the circle, that line is 1.618 times further away from the center. And there's a similar spiral called the Fibonacci spiral, where the arc is based on Fibonacci numbers. It looks like a nautilus shell, giving us the nautilus shell on the first page. And if you take a look here, here's where we get the Fibonacci numbers. 1, 2, then 3, 5, 8. And this is giving us where the spiral is going. It's lining up on these corners of the circles. And each of those lengths is another Fibonacci number. But enough boring math stuff. Let's actually talk about the art and nature part of this presentation. The golden ratio shows up in a lot of ancient architecture and works of art. Probably most notably the Parthenon. If you take a look at the diagram down here, you can see where the golden ratio can be found along the base, the pillars, and the top itself. But here's an interesting fact. It's been suggested that they didn't really know much about the golden ratio at the time they were building it. And today, since it's such a phenomenon, I guess, people measure from where it's most convenient, so they get the best approximation of the golden ratio. So what this means is it just might be an interesting coincidence that this building was built to the proportions of the golden ratio. But why is this? Basically, they say because it is so visually pleasing that they use it almost subconsciously. So here's a little experiment. Basically, when people were given the chance to pick the most visually pleasing rectangle, most people choose the one closest to a golden rectangle. And like I said, a golden rectangle is a rectangle whose sides are in the golden ratio. And which one is that? The one in the middle? Yes, that's it. The side lengths of this rectangle are in the golden ratio. It's 1.618 to 1. Leonardo da Vinci, he's another pretty famous artist and painter and sculptor, architect, musician, lots of things. And many of his works have been examined for their relationship to the golden ratio. And their appearance is a lot less coincidental than it was in maybe those ancient works. This is because Da Vinci worked with a friar named Pacioli, who published a work called the Divina Proporzione, which basically was a book that talked about the golden ratio and made it much more well known than it was before then. So as you can see here in this self-portrait he did of himself, you can see this big rectangle, which is a golden rectangle, and then some smaller ones you can connect to see golden rectangles within the facial features on him. The Da Vinci portrait. The face of the Mona Lisa fits nicely within a golden rectangle, as you can see over here on the right, with her whole body fitting inside this golden triangle, which kind of like draws attention up to her face up there. And you can also kind of draw this set of squares here and get an approximation of a golden spiral, or Fibonacci spiral around her. And lots of his other works, like I said, also have some relationship to the golden ratio. These works include the Vitruvian Man, which is up here on the top left, the drawing of the head of the old man on the right, the Last Supper down here, the Annunciation, St. Jerome, and both of his Madonna on the rocks as well. I also like to consider myself something of an amateur photographer. I run around with my smartphone and snap pictures all the time. And there's this rule of thumb called the rule of thirds, where basically you divide a photo into 3 equal parts, and you try to align elements of the photo along the lines it creates. When I was doing my research, I came across a more exact of this rule of thumb, so it wasn't really a rule of thumb, it was more of a law almost. Basically, if you divide the photograph into parts proportional to the golden ratio, 1 to 0.618 to 1, you can also create interesting compositions. But Alex, anybody can draw a grid and say it'll make pretty pictures. So let's take a look at some actual examples of this. Here's two I found during my research. The photographer here kind of aligned the horse with this line here, and you can see in this one it's also with the doors and such. But if you remember what I said earlier, we were just going to take famous works of art as givens for being beautiful. These are just two random photos some guy, James Brandon, took. So maybe I should give you guys a more famous example. Here is the Annunciation by Leonardo da Vinci. And if you can imagine lines dividing it into those proportions along the sides and the top and bottom, you can kind of see where it's divided along the railing back there and dividing the angel on the left and on the right to get this composition. You can also use the golden spiral to make interesting compositions, as we kind of saw with the Mona Lisa. But here's two more pictures that James Brandon took. One of some guy where he kind of aligns the line of it along his eye, and another where basically the center of the spiral is around the car line. I think these are pretty pictures, but you don't have to take my word for it. Math and music also have an interesting relationship. Many aspects of music are related to the golden ratio, like in Mozart's sonata form. You have the exposition, and then the development and recapitulation. In his first sonata, it's 38 counts and 62 counts in the second half. And using natural or whole numbers, you can't divide it any closer to the golden ratio. When you do, you get 1.631. In musical composition, you can also see the Fibonacci numbers. There are 13 notes in the span of any note through its octave. A scale is composed of 8 notes, of which the fifth and third notes create the basic foundation of all chords, and they're based on the whole tone, which is 2 steps from the root tone, and the root tone is the first note of the scale. And all those numbers I just put off were Fibonacci numbers. So in nature, you can also see relationships to Fibonacci numbers and the golden ratio, like the nautilus shell, and in seed heads on flowers. In the sunflower, the spirals going clockwise are 34, and the ones going counterclockwise, there's 55 of them. And those are both Fibonacci numbers as well. And I think sunflowers look pretty, but that's just me again. Also, the numbers of petals are also Fibonacci numbers in most cases. This is why 4-leaf clovers are rare. 3 is a Fibonacci number, 4 is not. But this isn't always the case. Fuchsias have 4 petals, crocuses, narcissuses, and amaryllis all have 6, as you can see on the top and the bottom there. So in conclusion, basically, without mathematics, there is no art, as Luca Pacioli said. He was the guy who wrote the Divina Proporzione. Basically, math is important in making kind of mindful constructions of art. And as we saw, they used it almost subconsciously in a lot of earlier arts. But once we realized that people like Da Vinci used it in almost all their works. And kind of their appearance, like where they show up naturally, kind of gives them a sense of like being everywhere at once, which is pretty cool. So, that's it. Questions?
Do you use Instagram?
Huh? I do like taking Instagram. I'm Alex the Wolfe. If anyone wants to follow me on Instagram.
I'm serious. What is it? Alex Wolfe?
Alex the Wolfe with an E.
Okay. How do you fit them into the square format if you're following those rectangles?
It doesn't have to be a square. Like that. The slide back here, I'm pretty sure the frame was a square.
Hold on.
The beat of him clicking.
This was pretty squarish.
Yeah.
So it's more of a ratio. It's not exact like measurements. Basically, and this is a square frame. So if you took all these lengths, this is 1 to 0.618 to 1. And if you were to add those together, that's like the whole frame. So there's basically 2 larger sections and the smaller section in the middle. Does that make sense?
Yeah.
Other questions?
Have other people studied a lot of other compositions by Mozart and Bach?
Yes. Interesting, when I was doing my research, in Mozart's compositions, they kind of like took a look at several of his other sonatas as well, and basically did kind of a statistical test. And they basically found that it was statistically significant that the proportions between the first part and the second part of his sonatas trend there. It was almost always in the golden ratio.
If someone's own proportions or their facial structure was close to the golden ratio, would that mean it could be considered more beautiful?
Technically, I couldn't find it when I was doing my research here, but I once saw like a face that was supposedly constructed exactly using the golden ratios, and it was a pretty face, but
Well, that kind of plays into the question that I have. It's somehow clinically talk about how infants at a very early age will show a preference for symmetry when they look at a face and rate it as more, well, their eye gaze is longer when it's a symmetrical face. Did you come across any research about sort of human nature in mathematics and
no, I did not get a chance to look at that, but there's probably a trend there, I imagine.
All right, we've got to move on, but if you could please help me thank